Is my screen visible to everyone?
Yes, sir.
Yes.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
As you can see the title, and which is the mathematical paveway for engineers. Actually, what is this? So in this paveway, we try to simulate, or we try to amplify your ability or knowledge of mathematical skill, and which is a necessary part of your engineering course. Okay, so that your remaining journey or the upcoming journey will be easier. Okay. So Shourov already in the previous class discussed about the differentiation question. Am I right?
Yes, sir.
Yes, sir.
Yes, sir.
Sir.
And now you know how to calculate the differentiation of a function. That means how to calculate the rate of a function, rate of changes of a function. You know that how to calculate that. Okay. Now, suppose you know the rate of change. Okay. You know the differentiation of a function, but we want to actually extract the original function from that data. Then how we can do that? That is our today's topic, and you most of the majority of you already familiar with this topic, and which is the integration, and it is a mandatory part of your class 12 exams. So is there anyone who have no idea about that integration? Is there anyone that how to perform the integration and what is the integration? If there is anyone, please tell me, and that will help me to conduct the class as per their way, as per the all's way. Is there anyone? So, okay. So if not, I take that you all have a minimum knowledge about what is integration. So let's start the topic. So first of all, what is indefinite integral? So basically you all know that the integration is the inverse process of differentiation, which I say today. So suppose you have a function, and just 1 minute. So suppose you have a function of this type x cube. Okay. And you know that how to differentiate that function, how to perform the ddx of that function, and what is the value? What is the value of that?
3x square.
3x square.
Because you know that this is 3x square. That means whenever you divide that function by 3, and you will get x square. So this is the differentiation of that function x cube by 3 will be x square. Now integration is just nothing but just the inverse operation of that. So whenever you take integration over that function x square d of x, and you will get this function x cube by 3. So basically what I want to say, that whenever you perform a differentiation, you will get another function, and if you take the reverse process, you will again get the original function. So now in our today's class, we know that data. That means we know that the differentiation of the data, and we want to extract the original function from that data. So let's take a look on that. So if the derivative of that f of x is small f of x, that means what we take? We take a f of x function here. Okay. And then we perform the ddx over that function. And what we get? We get some ddx of f of x function, or you can say that as f dash of x function. This is the derivative of the function. Now, we say that this f dash x is equal to a small f of x. We denote that by small f of x. Now, whenever you take integration on that function, small f of x function, f of x d of x, and you will again get that function f of x. So this is the way. So from f of x, you will get the small f x function. This is the differentiation of that function. And this function is called primitive of that function. Primitive of that function. I think you all know that. What is the primitive? That means this f of x is the derivative of a previous function, and this function is called the primitive function. Now, what happened? If we put a constant here, suppose we take a f of x plus c here. Then again, whenever you perform that ddx, you will get the same result. You will get the f dash x. Am I right?
Yes, sir.
Yes, sir.
Because this constant will give you 0. So that means whenever you back from that f dash x, back from that small f of x, you will get integration over f of x dx, and which will equal to the f of x plus c. So what happened here? So if you take f of x, it will give you small f of x, and simply again, when you take a capital F of x, it will f of x plus c, it will also give you the small f of x. That means addition or subtraction of a constant will not affect your derivative, and whenever you take the reverse process, it will a free element which you get in every performance. So what we can conclude? We can conclude that integration, indefinite integral, is not a unique process. That means you can get the functions, okay, but you can get arbitrary constant, which is called the integrating constant, bundled with that capital F of x function. So we can say that integration over that small fx dx is equal to capital F of x, and which will imply that ddx of f of x will be small fx, and integration over that small fx will be your capital F of x. And not only that, f of x, you can extend that up to addition or subtraction of a constant. That means whenever you add or subtract a constant, which is called the integrating constant here, it will not affect the derivative, and you will get that in every process of indefinite integral. So let's look in the next part. Okay, just 1 minute. Okay. So from the differential, which we learned in our previous class, we will formulate some formulas which will help us to calculate the integrations. So how we can convert the differentiation to the integration? Suppose this is the differentiation. You all know that, na? ddx of x to the power n by n plus 1 is equal to x to the power n. That means suppose you take x to the power n plus 1 over ddx, and it will performs like 1 by n plus 1. Take that outside, and this x to the power n plus 1 will give you another n plus 1 and x to the power n. Am I right?
Yes, sir.
Yes, sir.
So these two terms will be eliminated, and you have
Yes,
x
sir.
to the power n. Okay, so I want a interactive classroom. Okay, not of this type. So if you interact, then it will be easier for me to identify the laconis of every one of you, and so that I can help you. Now take a look on that. If ddx of x to the power n plus 1 by n plus 1 will give you the derivative x to the power n, that means obviously the reverse process, that means integration of this will give you x to the power n plus 1 by n plus 1, and this is the result. But you have to note that this formula does not work for n is equal to -1, because if you take n is equal to -1, and this is undefined term, so for integration over x to the power n plus 1, you can use this formula whenever this n not equal to -1. So this is a very simple formula which you can use. So suppose if we say that what is the value of integration over dx? Someone please tell me the answer. What is the integration over dx?
Sir, x
X plus C.
X
plus C.
Okay, this is a x plus c.
plus
You
C.
have to give one constant with every integration, because this is an indefinite integration and this is not a unique. You have to add one integrating constant in every term. So here integration over dx will be x plus c. So actually, what is our algebraic expression here? Actually, this type of expression is called algebraic expression, na? So actually, this is the algebraic expression. What we can say. Now take another example. Suppose you have to evaluate that x to the power 2 by 3 dx, and someone help me to solve that.
So x to the power 2 by 3 plus 1 by 2 by 3 plus 1 equals
2 by 3 plus 1.
What is your name and from which department you work? Hello.
Sir, Shiv Prakash,
Okay.
CSE.
So integration Okay. So integration will be x to the power, what is the value? That means x to the power 2/3 and plus 1. You have to add 1 in the numerator and divide this by the same power. That means 2/3 plus 1. This is a very simple way. And plus you have to add 1 integrating constant here. That means suppose take another. Suppose you have to calculate x squared d of x. That means you have to just increase the power of the function with 1. That means
x
x power
3 by 3
power by 1.
X cube by
And
3
then
plus C.
by 1. This is plus c. That means you have got x to the power 3 by 3 and plus c. And here, what do you got? You got x to the power 5 by 3. And I think this is a term which is again 5 by 3 plus c. And if you simplify that, you got 3 by 5 and x to the power 5 by 3 plus c. Okay, sometimes this term can be represented in this way. That means the cube root of x to the power 5. Are everyone familiar with this form?
Yes, sir.
Yes, sir.
Yes, sir.
So
Yes, sir.
this is a familiar form of the 3 root of x to the power 5. So this is a basic integration. Now, actually come to what happens if we take n is equal to -1. If we take n is equal to -1, then that means you have x to the power -1 term. Okay? So x to the power -1 means 1 by x term. And please tell me which constant give you the differentiation 1 by x, and that will be the integration of this term.
Log x.
Log x.
Okay.
Log x.
So
Log X, sir. Log X.
yes. Thank you. So log of x, and this is a tricky term actually. So whenever you use this type of term, a log of x, and you have to mention that which base you used. Now, so if this is the general log, then this will take the e base, and you all know that, and which is represented by ln x function. So if you take simply log x, and then there is some doubt that is the base 10 or is the base e. Okay, there may be 10 base or maybe e base. So if we take that as a ln x, then we clarify that actually it is the general log function and with the base e. So in every type of integration, we use this ln function. Actually, our integrations will give you the form with this ln x. But in calculator, there is two basic terms. One is for log and another term is for ln. But most of us actually make the mistakes that we use the log data in place of ln data. Okay, suppose in a math, you have log of 25 in a definite integral. It comes. So actually, that means it is the log 25 base e. This is the general log, not the base 10 function. But in your mathematical calculator, the log actually it represents the 10 base log. And the ln function will represent the general log, and which comes with the base e. So I suggest that whenever you perform this type of integration, try to use the ln function, or take this in your mind that the function used here is the e base function log. Okay.
Yes,
Is it
sir.
clear? If there is any doubt about that?
Yes, sir.
Yes, sir.
Okay. So let's come back to our actual discussion. And here we take another problem, and you can take that as a homework, and you can calculate that very easily. Someone tell me the answers. We'll perform that, and then we come to our next part. What is the answer?
X to the power
That means
-3
integration
by
over -4d of
X to the power
and then
minus
what
three
will
by
minus 3 by
X to the power -3 by
X to the power minus 3 by -3 plus C.
Ekdam. Thank you. Plus C. That means this is the x to the power -3 by -3 and plus C. So this is the integration. So now we come to our next part, another formulas from differentiation to integration, and which is corresponding to the ln function. Again, there is a tricky term. In our engineering view, actually we use the real functions always. Most of the problem actually occurs with the real functions and consists the real problems. So here the ln function also a real function, and I think majority of you know that this ln function of the log general log function is not defined in 0 or in the negative interval. Am I right?
Yes, sir.
Yes, sir.
Yes, sir.
Actually, this domain of that log function is the R plus region. That means it is defined in only the positive real number. So that's why we take that modulus here, because without this modulus, this ln function can be undefined. So this ddx of ln x gives you the 1 by x. That means obviously the integration will give you the ln 1 by x d of x will give you the ln function of modulus of x plus c. You all know that. Now take one example to clarify the usage of this function. And say, take that problem. And someone help me to solve that problem. How we can solve that?
By
Divide
dividing
part by x square.
Example. Dividing partially that term, that means first term will give you x to the power 4 and x square, that means x square d of x. And if we take the second term, that will gives you minus of integration, what? 1 by x.
1 by x.
1 by x dx. And the
And
third
plus
term, if
2
we
by
take that 2
2 by x
outside,
square dx.
we
Integration
have x to the
integration
power
of
minus 2. Or,
x
okay,
minus
we
2, x to
take
the power
one
minus
step, 1 by x square d of x, and then we calculate that. So actually this 1 by x square, and this is the term which you can write that x to the power minus 2. No?
Yes.
So we put that terms directly here. That means we put that x to the power minus 2 d of x, and which will give you that sum is
So
equal to x to the power
x to the
3
power
by
3 by 3
3
Minus
minus
log x.
x to the power
Minus
minus
log x.
ln of
minus
modulus
log
of x,
Minus
okay,
2 by
and
x.
plus 2 into x to the
x
power
minus 2
minus
plus
1
minus 1 by
By
minus
minus
1
Minus 1.
plus
and
3.
don't forget to add one integrating constant here. Okay, so this is the integration value of the integration, and you can express that in a simpler way by taking that x cubed by 3 and minus ln function of modulus of x and minus 2 by x and plus c. Okay, so this is a simpler form and easy to understand. So this is the process how we can use that ln function. So suppose if here this type of functions, you already know or familiar with this type of function also, the exponential function. Okay, and Saurabh sir already cleared this topic, that how to perform the differentiation of the integration of the exponential function. So that's the differential of the exponential function, the simplest exponential function, and which is ddx of e to the power x. You know that this is the exponential x itself. Now, obviously, so if you take integration from this side to this side, and you will get again e to the power x. Now, what about the general exponential function? General exponential function means a to the power x function. Na? This is the general exponential function, and where this a take not equal to 0, and you can take 0 to take a not equal to 1, and you can, okay, just 1 minute, and this a greater than 0, you can take that. For any a greater than 0, this function will be defined, and this is the differentiation of that a to the power x. So whenever you take differentiation of a to the power x, what do you get? ddx of a to the power x. Someone please tell me what is the differentiation of that?
Sir, a to the power
A
x
to the power
log
x.
n.
To the power x log x.
What is the ddx of a to the power x? ddx of a to the power x. Please tell me again.
A to the power x by log
power
x.
x log a base a.
Not log a.
Into log a base e or ln of a function. This is the differentiation of the general exponential function. So whenever you divide that by ln a function, or you can take, where we say that a greater than 0, so don't need to take any modulus here. This is already defined term. So whenever you divide that by ln of a, actually it will give the a to the power x, because a to the power x give you a to the power x ln of a function. That means whenever we divide that function with the ln of a, you will get the a to the power x again. So obviously, if you take integration over that part, you will get back this a to the power x by ln of a function. And this is the formula for the exponential function, general exponential function. So what happened if you take integration over that e to the power 2 of x dx? Is there anyone who can tell me what is the value?
Divided 2x by 2.
Sir, e to the power 2x
Power
2 plus c.
2x by 2. Correct. So e to the power 2x by 2 and plus integrating constant c. That means whenever this type of function comes with your function x and you have to divide the x will give you e to the power x by a and plus c this
by
type of function.
a plus c.
Yes, yes. So I think most of the students are inactive in this classroom. Why? I don't understand that. But I welcome everyone to ask their questions, ask their doubts. Okay, so that I can clear that.
Sir, actually,
So-
can we write log a instead of ln?
Obviously, you can write, but actually you have to take that in your mind that this log of x function will be e-base function. Obviously, you can write that. Okay, most of the standard book also use this type of notation log of x and they consider that this is a base e function. Okay.
Yes, sir.
You can also write that, but why we suggest? Because whenever you use that for calculation by using calculator, most of the people make mistakes by using a e-base ln-base function to a log-base function. Okay, you can see that in your calculator there are scientific calculator there are two terms. One is for log and another is for ln. So we generally try with the log function, but when we use, we also use in the log function, and that's why the error comes. Am I clear?
Yes, sir. Yes.
Yes, sir.
Okay, you can use that for your integration performance, but make sure that you will not make the error whenever you calculate that term, calculate the real values. And obviously this mod of x function you have to use and whenever you take the integration, because x function sometimes may be negative because x is from the real number. So that's why we take the mod term and for safety. Okay. Otherwise that functions may be undefined. So let's take one example and you will help us to calculate that. So please tell what is the value of that integration. We have to calculate integration over 2 to the power. So
3
2 to the power x
plus
plus
c.
3.
So first,
2 to the power
what
x
we
plus
do?
3 plus c.
So first, what we do? First,
Sir,
we
we integrate
divide that
a to the
function.
So
power.
First,
actually,
we
2 to the
divide
power
that
x into 2
function.
to the power 3.
Ekdam 2 to the power 3, 2 to the power x into
Yes,
2 to
yes.
the power 3 of dx.
And to dx.
And it
So then
will
we
gives you 8 into integration over 2 to the power x d of x. Okay. Now this is 8 and this 2 to the power x will give you another 2 to the power x and by is using what? Ln function of 2.
ln2
Ln 2 plus 3.
And then another integrating constant is equal to c.
plus c.
And this is your integration. That so we can actually again merge these two functions by using that 2 to the power x plus 3 and by ln of 2 and plus c. Okay, you can again merge these two.
Sir, আমি এটাই করেছিলাম।
Ekdam, I understand, but actually I want to exclude that function so that everyone understand this. Okay, you are absolutely right in your step.
X by ln a, a to the power x by ln a, a to the power x by ln a.
Okay, okay. Is there any doubt in this performance? Is there any doubt?
No, sir. No, sir. No, sir.
ও স্যার
Let's come on next part, and which is we know the mostly used function and which is the trigonometric function, and you can see that everywhere in every place there are trigonometric functions, and there are so many trigonometric functions. That means sine of x, cos of x, tan of x, and everyone have a basic differentiation.
Yes.
So you know that. So I will not wasting time here. So ddx of sine of x will be cos of x, and you know that integration of that cos of x will be obviously
Sin x plus c.
Sin x. So again, what is the ddx of cos of x? Cos of x will give you minus x, minus
Yes,
sin of
yes.
x. ddx of cos of x will give you minus of sin of
Yes,
x.
yes. Minus sin x.
That means
Minus sin x.
take the minus here. ddx of minus cos of x will give you the sin of x function. What is that?
Yes, sir.
ddx of
Yes,
minus
sir.
cos of x will give you sin x. So obviously, whenever you perform that integration over sin of x, and again you will got that minus cos of x function. And similarly, if you have ddx of tan of x, which will give you sec square x, and if you perform the integration over that sec square x, you have the tan of x plus c. And then for the cot x, again a minus occur here, because the ddx of cot of x will give you the minus cosec square x. Okay, so that means minus cot of x you will give you the cosec square x, and that's why the integration of the cosec square x will be the minus cot of x plus c. And similarly for the sec of x function, you all know that sec of x will give you the sec of x plus tan of x, and that's why if you take the integration over that sec x tan x function, and it will give you the sec of x function. And similar term for the cosec x, actually cosec x will give you the cosec cot and with a minus sign bundled. So that's why that minus cosec of x will give you the cosec x cot x, and it will give the cosec x. Okay, is the full screen visible, or there is the screen for this Zoom also?
No, sir, it's completely visible.
No, sir. This is perfect, sir. This is perfect.
Okay, okay. Okay, so let's come to one example, and so that you can solve that. Just 1 minute. The previous page, and so again, suppose we have to perform the sine of ax dx, integration over that sine of ax d of x. Then what we have? That means this type of term. That means sine of 2 of x d of x. What will happen?
Minus cos
Like the exponential part.
Minus cos 2x by 2.
So first term is minus cos of 2x, and
Sir, minus
for
a
this
into
2,
cos
Minus
a.
cos plus by 2, sir.
so
Plus c.
minus cos of 2x, and you have to divide by 2 and take one integrating constant here c. So everywhere if there is a bundle here, so actually you have to divide that in your answers. So that means integration over sine of ax will give you the minus cos of ax by a and plus c. And actually it will, you have to perform that with every term, for the sine, for the cos, for the tan, in everywhere. If this type of integration will occur, that means the sec square of 5 of x d of x, that means what is the answer here? What is the answer?
5x by 5. 10x 5x by
5 plus c.
This is tan of 5x, and
by
for
5.
this 5 you have to divide by this
Constant.
5, and then you have a constant c. And for the others remaining part, for the cosec, for the cot, everything is same, just like that. So now we take one problem, and which is something, if you have to evaluate this integration, how you can integrate that. Suppose this is a term
Sin x minus
the
cos x
integrand.
whole square.
Huh? Yes, still.
That
Sir,
1
1 minus
sin
sin x cos
sin x minus
2x will be 2
1
sin
is equal
x.
to sin square x plus cos square x.
minus
Yes,
2
yes,
sin
yes. What do you?
Minus
Please tell your
sin
name.
2x 1 to sin x
Say that
Sin
one
x
word
sin
first.
x square
plus
Sorry,
cos
please
x
tell your name.
whole square.
Actually, sine 2x formula will be 2 cos x into sin x. So firstly, we have to written this root over 1 minus 2 cos x into sin x dx.
हाँ,
So
root over
1 will have
बोलो
to
1
make
minus
sin square theta plus
one time 1 minus 2 cos of x and sin of x, and then what
Sir,
you can do?
one,
Sir,
sir,
change the 1
1
as
will
sin square
sin
x plus
square
cos square
x.
x plus cos
Sir, root
square x.
over
Ekdam. That
cos
means
x
you have
minus
the
sin x
sin
per whole
square
Sin
x
square x
and
plus cos square x
plus
minus
cos
2
square x and minus 2 sin of x into
sin
cos
x
of x.
cos.
Yes, sir.
That means you have root of sin x minus cos x and whole square of that. Sin x minus cos x and whole square of that. Actually, this will give the sin of x minus cos of x term, right? So whenever you have to perform that integration, you directly put that function here. That means sin of x and minus this is the cos of x, and again take that as d of x. Now what will be the integrations? Tell me.
So
minus
Minus
cos
x
x minus sin x
sin x
plus
Minus
c.
sin x plus c.
Minus cos x, and for the cos x you get sin of x, and then this is plus c. This is the integrating constant. Here in every term, this is the integrating constant. Okay, this is
Yes,
the
sir.
integrating constant. Remember that. Don't forget to add that in your indefinite integral. For definite integral, there is no constant. You will see that. And then there is another type of function we missed, and actually which is the inverse type function. Okay, we already know the algebraic function, the trigonometric function, and the logarithmic function, exponential function, and we left the one function which is called the inverse function. So what is the formula for the inverse function? So inverse trigonometric function, you all know that ddx of this sine inverse x is 1 by root under 1 minus x square. So sir already discussed that in your yesterday's class. Am I right?
Yes,
That
sir.
Yes,
differentiation of the
sir.
inverse function.
Yes,
And so ddx of this function sine inverse function of x will give you the 1 by root under 1 minus x square, and that means the integration of that function will again reverse. If you take the reverse, will give you the sine in over 1 by root under 1 minus x square is equal to minus of sine inverse x is equal to sine inverse x, sorry, and plus c. And there are some similar expression for the sec inverse x, 1 by root under x square minus 1, and you all I think know that, and this is the formula which you have to use directly in your maths, and this is the formula for the tan inverse x. Okay, just take a close look here. So for the sine inverse x, actually you have 1 minus x square term here, and you know that for the cos inverse x there is a minus, na?
Yes, sir.
Right?
Yes, sir.
Cos inverse
Yes, sir.
term. So actually you can perform that integration by using cos inverse also. That means if you take, here is 1, so if you take one minus here and another minus here, so it will give you minus of cos inverse x and plus c. Okay.
Yes,
Is
sir.
there any doubt? Yeah. That
No,
means
sir.
we take just two
No, sir.
minus here. That means that if you take the cos inverse x here, so you will get the derivative minus 1 by root under 1 minus x square. That means we rearrange this term in this way, that 1 by root under 1 minus x square, we take one negative here and we take another negative outside. So this term, integral term, will give you the difference, the integration cos inverse x, and with this negative sign in the outside. So that means you actually have, you can express this integration by using sine inverse x also and by using cos inverse x also, and these two answer is absolutely right. Same case for the sec inverse x. For the sec inverse x, you have that, and if you take cosec inverse x here, actually you have a minus here. So that's why this term can be expressed as minus of cosec inverse x and plus c. You can express that. And similar for the tan inverse x also. Tan inverse x will give that, and obviously cot inverse x will give the negative term, and that means this term can be expressed as minus of cot inverse x and plus c in this way. Okay, so these are the forms for the inverse trigonometric function, and you can use that for your maths. So let's take one maths and try to solve that problem, and tell me how we can solve by using the inverse trigonometric function. This, tell me. Is there anyone who can give me some
First of
ideas?
all, we
How
will
to
be doing
X
plus 1 minus 1.
X minus 1 by X
plus
plus 1
1
plus X
minus
plus
1.
1.
Someone tells that plus 1 minus 1, that means x square minus 1, and we take another plus 1 and another minus 1. Okay, and we have x square plus 1 into d of x. Okay, am I right here? Is this correct?
Yes, sir.
Yes, sir.
Okay, now what we take? We will rearrange again. Now we will take x square plus 1 together, and then
Minus 2.
we take minus 2, and here we have x square plus 1 into d of x. Now partially divide that into two parts. That means integration over x square plus 1 x square plus 1. That means this will give you dx, and minus, if you take 2 outside, it will give 1 by x square plus 1 into d of x. Okay. Now tell me what is the formula for the integration?
X minus 2 tan inverse x.
Minus 2 tan x minus 2 tan inverse x plus c.
X plus C. X plus C.
Minus 2, this will give you the tan inverse x and then you have integrating constant c. So this is the term for the inverse function. I think you all understand that. Up to now, is there any doubt?
No, sir.
No,
If there
sir.
is any
No, sir.
No, sir.
No, sir.
Okay, let's come to our next part, and which is the integration by substitution. So what is the substitution? So sometimes it will happen that the more complex form will occur in our integrations, and then we can substitute some terms with by t or with by z, and so that our integration converted into a easier form in the previous form, so that we can perform that integration easily, and that is called the integration by substitutions. And this type of forms, you are familiar with that. Suppose this type of form comes that 3 plus 2 of x whole to the power 5 of d of x. This type of integration occurred. So this is a 5 terms. If you express that binomially, it will be tedious and time consuming. So that's why we have to take some substitution to perform that, and after that your integration will be easier. Okay, you all know that very well, that how to perform this type of integrations. Am I right? How to calculate that? Someone tell me.
So take 3 plus 2x
We
equals to
can
3.
3x plus 2 as
So we take that 3 plus 2 of x, a t, another variables, and that will convert your, then after differentiation you will get 2d of x is equal to d of t. That means your d of x will be defined by dt by 2. So now your integration will convert it into integration over t to the power 5, and here you have, in the place of x, you have dt by 2. So that means you have 1 by 2 integration over t to the power 5 into dt. And I think it is one of the form we discussed previous, and this is easier to perform the integration. So that's called the integration by substitution method. So we substitute some favorable form so that it can convert it into a easier form, and which we can perform easily. So this is, what is the integration of that? Tell me, what is the integration?
3
So
plus
3 to the
2
power
x to the
6
power
by
6
6.
by 12 plus 6.
by 12.
That means, and this is, just 1 minute. So this is 1 by 2 into, you have t to the power 6 by 6 and then plus c. That means you have 1 by 12 just to back that value of t, and which is 3 plus 2 of x and whole to the power 6 and plus c, which is the integrating constant. So this is the method of integration by substitution. Now it comes to our theoretical part, and which is the theorem of that. So if we have to evaluate an integration of that type, that means there is a function f of phi of x. That means f is a function of phi of x. You can see here that here this function is again a function of 3 plus 2 of x. That means your t to the power 5, which is a function of 3 plus 2x. You can say that na, the t is a function of x. So that means f of phi of x, in this type of problem, you have to take that phi of x is equal to t. You have to take that phi of x is equal to t, and that will give that phi dash x dx will be dt. Then substitute that form in that phi dash x dx, and this will give you a easier form to integrate. Okay, this is the process. So take one problem, and this is a similar problem of these types, and I think you can easily calculate that. So someone help me to solve that. This is the same problem with the negative power.
We can take 2 minus 3x as t.
Just give me the answers. Okay, I will just put the answers here because you all know how to perform that integration. Someone please give me the answers. Please make the solution and give me the answer.
Sir, can I?
Yes, just take the time and calculate that, and then give me the answer. The process will be the same as per that. We have to take that term is equal to t.
So 1 by 3
minus 1 by 9. 2
Someone
minus
tell me
3.
1 by 3.
1 by 3
3
bracket 2 minus 3x whole to the power
2 minus 3x. Okay.
whole to the power
And
minus
we take whole to the power minus
3 plus c.
3 plus c.
So
Okay.
for in the first it will be
Right.
minus.
I think one term is missing here. Nah, this minus 3 term, where is that? Whenever you take that, t is equal to 2 minus 3x, actually after differentiation, what you will get? Okay, just 1 minute. I will change the color of the pen.
dt equal to minus 3 dx.
Okay, just 1 minute. I will change the color of that term pen. So if you take the t is equal to 2 minus 3 of x, then you have dt is equal to minus 3 into d of x. Am I right?
Yes.
So that means
Yes,
your
sir.
dx will be
dt
dt by minus 3.
3.
See, so there is a term with that dt by minus 3. That means there is another part and which consists of the
It will
minus
be
3.
1 by 9.
Minus
There is
1
a
by
minus 1 by 3,
Minus of
and
1
then
by
again
9.
1 by minus 3 here for that term. Nah? And for this integration, you have again 1 minus 3. That means actually you have 1 by 9 into 2 minus 3x to the power minus 3 and plus c. So this is the integration.
Yes, sir.
Okay. Yeah, this is the actual answer of your problem. So now comes to another problem, and which you can solve by substituting something. Now someone tell me what we have to substitute here.
Z equal to
Substitute
Ln x is equal to t.
Constitute or ln of x is equal to t.
Then dx by
after
x will become dt.
After differentiation, actually we have 1 by x into d of x is equal to dt. So now just put that whole term, that is dx by x equal to dt, and your integration over you have sec square t into dt. All right.
tan ln
So now
x
you
plus c. Tan log x plus c.
so
Tan
this is
ln x
tan
plus
t
c.
Tan
c.
t plus t.
That means this is called the tan
So
of
tan into
ln of
ln
x
x.
and plus c. Okay. So this is your integration, and that's very easy. So after substitution, you can see that integration become easier. So this is a complicated form, but after substitution, we can easily calculate this type of integrations. Okay. Now take another problem, which is a problem, famous problem for substitution also, and this is actual formula. So what is how we can calculate integration over tan x?
Tan x is ln of sec x plus c.
Log mod sec.
Yes. And how we can perform that calculation? I want to know that.
We can break it into sine and cos.
Exactly. So we can break it into sine of x and cos of x, d of x. And after that, what we have to take?
We can take cos x equals to
Z
t.
equal to cos x.
And what is your name? Tell me.
Swastik Ghosh.
And from which
Data
department you are?
science.
Okay, thank you. So that means cos of x, you take that as a t. That means whenever you take the derivative, you have a minus of sine of x, d of x will be dt. So sine of x dx, the numerator part dx will be minus of dt
by t.
So just we put that here. That means minus dt by t here. So actually we have minus integration over dt by t. What is the value of that?
T inverse minus t inverse
minus ln of mod of t.
Ln of t.
Okay.
Plus c.
And plus integrating constant c. That means minus ln of mod of cos of x and plus c. So you know that on the log property that minus of ln of x can be introduced as ln of x to the power minus 1. Am I right?
Yes, sir.
Yes, sir.
Take that power here. So that's why you have ln of mod of cos of x and to the power minus 1 and plus c and cos x to the power minus 1, which is actually this is the 1 by x term now. So that means 1 by cos of x term, and which will give you that ln of sec of x plus c. Okay. So this is the process how we can calculate the formula, how we can use that. So there are some other formulas consisting of cot and cosec, and for the cot, cosec and for the sec also. And these are the formulas, similar problems, some, and with your result. So first of all, this is for the cot of x, and second for the sec of x dx, and which is ln of sec of x plus tan of x plus c. And there is another form of that function, and which will actually looks like that ln of tan of pi by 4 plus x by 2. Are you familiar with that form?
Yes, sir.
Yes.
Yes, sir.
Yes, sir.
Yes, sir.
And there is the third form, and which is for the cosec of x dx, and which is log of mod of cosec x minus cot x plus c. And for this also we have a familiar form, and which is ln of tan x by 2. So these are some formulas, and which actually these are problems and also formulas. If you take this as a problem, this is a problem. If you take that as formula, you can take that as a formula. So actually we have to remember the formula, and that will make easy to understand every other topics. If you want to calculate that, and it will be tedious. So okay, can someone tell me the process of calculating this differentiation integration cosec of x dx?
Yes, sir. At first,
Yes,
integration
sir. We take.
Yes, sir, we take.
into cos x minus cot x, and then
Then say 1 by sin x minus cos x by sin x.
তার তলায় স্যার ভাগ চিহ্ন দিয়ে cos x minus cot x ভাগও করতে হবে, মানে যেটা গুণ করতে হবে স্যার সেটা ভাগ করতে হবে।
একদম
তারপর
একদম। তো তুমি বলতে চাইছো যে cos x minus cot x দিয়ে আমরা নিউমারেটর এন্ড ডিনোমিনেটর কে প্রোডাক্ট করব, তাই তো?
Yes, sir. 1 by
So
sin x
let's
minus
take that.
cos x by sin x. Then
Just 1 minute.
by sin x.
Actually, sin x by cos x term will be tedious, and you have to take the previous method. There is another way. You can solve that also. First, who says I don't know? Can you give your name or say your name? What is your name? Who says that you have to product that? Who says that we have to product the numerator and the denominator with the cosec of x minus cot x? Please tell your name.
সর্বজয় ঘোষ।
Sarbojoy. Okay, Sarbojoy. First, I will take your ways, and then we comes to another ways. There is many other ways to solve that. Actually, there is a term also ln of tan of x. So you can go through this way also. But we take this way. Actually, it is easier way. So cosec of x, and you product that by using cosec of x minus cot of x. Am I right? And
Yes,
you
sir.
divide this term again by cosec of x minus cot of x and dx. So by
Yes, sir.
taking that, actually, then you put that the denominator is equal to t. That means cosec x minus cot of x is equal to t. So that will give you minus cosec of x, cot of x. And then for cot of x, what? Cot of x minus, and again another minus, that means plus, into cosec square x, d of x, and we take a bracket here, d of x will be dt. Am I right here?
Yes.
Okay. And you can see that actually this is the numerator part. Dekho, this is cosec of x, that means cosec square x, and the second portion is the cosec of x, cot of x with the minus term. That means this whole term actually represent your numerator. So you can directly put that values here, and which will give you the dt term. And in the denominator you have t.
Yes,
so
sir.
Now you know the integration is equal to ln of mod of t and plus integrating constant c, and which will give you ln of modulus of cosec of x minus cot of x plus c. Okay. Actually, after calculating that, you can also express this cosec of x minus cot of x in this way. Na? So suppose you take that cosec of x minus cot of x. You can express this as 1 by sin of x and minus cos of x by sin of x. Am I right? And after that,
Yes, sir.
just take the LCM as sin of x and calculate that 1 minus cos of x. Now someone tell
1
me
minus cos of x, yes.
Someone tell me the formula for 1 minus cos of x.
So 2 cos square x.
Sin square x by 2.
2 cos 2 sin square x.
2 sin square x by 2.
2 sin
Yes,
x,
sir.
sin x by 2.
Sin x by 2 and 2 into sin x by 2 into cos x by 2.
Ekdam. So 2 eliminated, and from here we eliminate 1 sin of x by 2.
Tan
Actually,
x
you have
by
sin
2.
of x by 2.
Tan x by 2.
This is the
Tan
second
x by
term
2.
which we familiar by that. So you can express this term with another term, and which is ln of mod of tan of x by 2 and plus c. This is the another expression by which you can express your data or express your result. So This is the second part, which is ln of modulus of tan of x by 2 plus c. Now comes to our next part, which is you already performed this problem, trigonometric identities. Actually, up to now we use that. We already used that, the trigonometric, how we can use the trigonometric identities to make the form simpler for the integration. So here there is a just gentle note, and which says that whenever the integrand consists of trigonometric function, we use some known identities to convert it into a easy form so that we can easily integrate that. And there are some useful identities which will make your notes for your future use. Actually, you can use that note for your future use. That's why we put it here. So there are some formulas, trigonometric formulas, which can rapidly used in your subject or in performing this trigonometric types of integration. Okay. So then comes one another problem, and which is how to evaluate that integration over sine square x by 2 d of x. Someone help me to perform that.
So at first,
1 minus cos x
1 by 2.
1 by 2 into
Sin sine square x by.
so
Okay, so first of all, tell me the formula. What is the formula?
1 by 2 into 2 sin
1 minus cos x.
1 by
minus
2
cos x by 2.
2 sine square x by 2 into d of x.
Yes.
Okay.
Yes.
Then
Okay. So
we
now
write
you know
the
that formula.
minus cos x.
Then half
One
integration 1 minus
What is the
cos
formula?
x.
Cos
1
1
minus
minus
cos x.
1 minus cos x
1 minus
dx.
cos x dx. Then we can write half integration dx minus half integration cos x
Exam.
dx.
Half integration dx minus half of integration over
Cos
cos
x
of
dx
x d of x.
equal to
That
minus
means you have
x.
Half
Oh,
x.
this is x by 2.
half x by 2 minus half
This
into
is
sin x.
minus 1 by 2 into
Sin
sine of x and plus
Sin x
integrating
plus
constant c. Okay. Am I audible to everyone? Because I can
Yes, sir.
listen only
Yes, sir.
few of
Yes, sir.
Yes.
student.
Yes, sir.
6 to 7
Yes, sir.
student. Okay, I can
Yes,
listen you. But there are so many students. I can listen. Am I audible to everyone?
Yes, sir.
Yes,
Yes,
I'm audible.
sir.
Yes, sir.
I know you can listen me, but there are so many other students. They can listen me, or they can. Is there anyone? There are 178 participants I can see, but I can listen only 6 to 7 students
Yes,
here.
sir.
Most of the students are
Yes, sir.
inactive.
No, sir.
Okay. So let's actually try to interact in this session. It will be used in your remaining parts of your the upcoming portions of your engineering course. Okay, that's why it is necessary, and we put that as a mandatory part of this course. So now we take another problem, and this is a famous problem, and which will be used in your upcoming portions in every topic, and most probably in the 4-year, obviously. So how to perform that this type of integration over cos of mx and cos of nx dx, and where we take that m not equal to n. That means this type of integration, cos of 2x and cos of 3x dx, this type of integration. Okay, we used a general notation here so that we can perform everything. So here the term is cos of 2x into cos of 3x dx.
Half
So half into 2.
Now how we can perform that? Yeah, okay, if you take half into 2, there is no formula for that cos of 2. There is a formula for, you have to divide that, na? So
No, sir. So cos A plus B plus cos A minus B.
understand. Cos A, cos B formula, that means you have cos of A plus B and what? Plus or minus? Cos of A plus B plus or minus?
So plus.
So just integrate over cos of m of x into cos of n of x d of x, and you say me that you have to product by half and 1, 2 in the inside. That means cos of m of x into cos of n of x dx. Then divide that by using the trigonometric identities. What is the first term? Cos of m plus n x, and then plus cos of m minus n into x, and then there is a d of x. Now you can easily perform that integration. This is a simple cos type of integration, and what is the value of that?
Half sine m plus n x m
First
plus n
term is sine m plus n x by
by m plus n.
and for the second
Pure sine m minus
this is
n minus
sine
m
x
minus n
by
minus n minus
m minus
m minus n and with constant c.
plus
Okay, so this is the integration. So this is when m not equal to n. But if you take that as m is equal to n, actually it will convert it into a previous type of problem, and which is integration over. Whenever m is equal to n, your integration will changes to cos square m of x. No, this is cos. This is changes to cos square m of x d of x. Am I right? Whenever this n is equal to n,
Yes, sir.
if you take that,
Yes,
your
sir.
integration will change to cos square m x dx. So again, the same way like the sine square x. Tell me. What do you have to do?
1 by 2 into integration
2 cos square mx, or this is mx, 2 cos square m of x dx. That means 1 by 2 integration over, what is the formula for that? 2 cos square m of x.
1 pure cos mx.
1 plus cos
mx. Cos mx.
2 mx
2 mx.
dx. Na? So now perform the integration. You can easily do that. That means first term will give you 1 by 2 and first term will give you x.
And
And
sine
second term will give you sine of 2mx
sine 2mx
by 2m.
by this term, na? This 2 of n
Plus c.
and
plus c.
Okay, so this is the integration. Okay, now we will take another views, and which is a very necessary part of your course, which is integration by parts. So what is integration by parts? So by parts means when the integrand will consist a product term. That means some product of f of x into g of x, this type of term, g of x, d of x. So in this type of problem, you have to take one part outside and you have to retain one part in the inside. Am I right? Whenever you perform this type of integration.
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
So actually, whenever you got this type of function, that means f of x into g of x dx, you have to take one part outside and you have to take another part in the inside portion. And this performance or this process is called the integration by parts rule. And what we do here, actually, we do this type of integration. That means integration over u of x, v of x dx. So first, we take that u of x in the outside. Okay. First, we take that u of x outside and retain that v in the inside. And then what you have to do? You have to do a performance. Actually, see here, you can take one integration, then differentiate those functions which you take outside. First, you take u outside. So you perform a differentiation over that u, and you again take that integration over that v of x dx, v dx, which you take in the previous term. And after calculating this, you have to perform the integration again with respect to that dx. So this is the form. We will take some example to clarify that. So actually, this is the process. Two functions. One function you have to take outside and another function in the inside. So after performing that, again you take minus with successively with one integration sign, and then you perform the differentiation of the term which you take outside and integration of the first term. And then after performing that, you have to perform the whole integration. Now the point is you have to take one part outside. How you can choose that? Which part will be outside and you take outside, and which part will be
Islet method.
Island method.
Islet method.
So, Islet method means,
Sir, at first inverse, then logarithm, then algebra, then trigonometry, then exponential.
Exponential.
okay. So that's, you have to remember that. Okay. So this is the rules to be remembered, which is Light method, LIATA, and you all know that, which is first term, which is L, and this is what? This is the logarithmic function. and the second function, which is I, which is the inverse function, third function A for the algebraic function, and the fourth T for the trigonometric function, and then E for the exponential function. That means whenever this type of function comes, that means a logarithmic function and another inverse function. So you have to take the priority on the logarithmic function, you have to take that outside. So first function will come outside, and the second function in that order will remain written in the integration term, which will be taken first, which will be in that. Actually, if you take that order, which will be in the first, you have to take that outside, and the remaining will be taken in the inside term. So let's take one example so that can clarify it. Suppose, so we have the rule L, I, A, T, and E. This is the rule. Now we have X function, and which type of function is that?
Algebra.
This is an algebraic function, and this is an exponential function. Okay, exponential function actually always come to the last. Okay, because it will exponential, the differentiation, it will be again exponential, integration of exponential, again integration, it will never change. Okay, and that will create a loop for your integration. That's why we take that as the last. So this is a algebraic and this is exponential. So what term you have to take outside? You have to take that term which will come first. Algebraic. That means you take that X outside. Then you have to take the integration other term. That means e to the power x into d of x. Then you take one minus sign, hard bracket, and a d of x. Now the inside part will consist of the derivative of the term which you take outside. That means first you perform that ddx of the term which will take you outside, this term. In this third bracket, we will perform first the derivative of the term which we taken outside, and then again perform this integration e to the power x into d of x. Okay, and after performing that, we have to take the integration again. Okay, is there any doubt how we can perform that?
No,
Okay.
sir. No, sir.
I want to listen from everyone.
No, sir.
Is there only 5 students?
No, sir. No, sir.
Okay.
No, sir.
No, sir.
Just 1 minute. So now, what will be the integration? So this integration will be x, and e to the power x will give you e to the power x again. Then you have minus integration over ddx of x.
1.
What is ddx of x?
1.
1. And 1 and e to the power x.
E to the power x.
E to the power x. And then you have to take the integration over dx. And since we perform one integration, you have to put one integrating constant c here. Okay. So this is the integrating constant c. Now, actually we have x e to the power x and minus, again we have to perform another integration.
E to the power x.
E to the power
E to the power x.
Plus
And
c.
there is another constant. So we put a constant c prime, and which is c prime is equal to previous constant c and plus something, another constant c1, which will comes from here actually. So we change that constant of integration. So actually this is the value of your integration. So this is a partial by parts integration which will consist algebraic expression and one exponential form. So now comes to another problem.
Sir,
Can
can you tell me about LIAT, L-I-A-T? Actually,
Yes. Huh? Yes, tell me.
sir, LIAT.
Ekdam. So actually, LIAT, this is the rule. Which terms you have to take outside and which term you have to take inside. So actually, whenever these two terms occur, suppose one is u of x and another is v of x, you can see that. So we take one term outside and we perform the integration on the other parts. Now we have to decide which term will come outside. And this preference will govern by this rule L-I-A-T-E, LIAT. That means logarithmic terms first comes outside, then inverse term, then algebraic term, then trigonometric term, and then exponential term. This logarithmic term means any type of, this is log of x type term, ln of x
Hello,
square
sir.
type terms, this type of terms. Yes, yes.
Sir, I
Okay,
thought
sir,
that
okay.
here will be the rule is islet.
No, actually, there is a term is late. You can check that. Okay. I think some of the books
Yes, sir. Yes, sir.
consider these two
Yes, sir, this is late.
Okay. Actually, somewhere it is written that late, somewhere it is written that islet, IL. Actually, whenever they says that, whenever I and L comes together, so there is no preference in this rule. They says in this type, if inverse or logarithmic term comes, then take that outside. Then if algebraic term comes, then take it outside, then T. Actually, they took that two terms. But we actually here consider two terms in different way. We take that I term outside, L term first, and then I terms. Some of the authors take that islet, some of the authors take that rule late. Okay, you can check that on internet. You can see that somewhere this is light, somewhere this is islet. Okay, actually this L and I type of function, if occur, if you take any one term outside and another out inside, you can solve in both methods. Okay, is it clear? So
Yes, sir.
if
Yes,
you take islet,
Sir,
it
they
will
both are correct
gives
only.
you no problem. Yes, yes.
Sir,
Tell me.
sir, but in class 12, late will be given.
Actually, I say that some books will use late, and somewhere in internet there is also islet rule also. But
Okay,
actually, it will create no hazard in your problem. You can take that I outside or L outside. These two will give you the same problem. But don't actually interchange that for the algebraic, trigonometric, and exponential function. So we take light form, and from our starting education from our class 12 level to now, and it does not create any problem for me. If it creates problem for you and you can identify that and tell me, I will then give you the suggestion. Okay.
Okay, sir. Okay.
So now we comes to another problem, and which is the evaluate integration over x square and x dx, and how we can perform that.
We have to take ln x outside.
Outside. We have to take that ln of x outside, and then you take integration over x square over dx. Okay. And then minus, you have to take in that integration and following by a third bracket of dx. Just perform this ddx of that function which will you take outside, na, ln of x. And take integration over this function x square dx again. So this is the format. That means you have ln of x into, here you have the integration x cubed by 6, na? And minus, this is integration over ln
1
of
by
x.
x.
What is that? 1 by x, and you have x square means
x cubed by 3.
Of x and plus c again. Okay, so actually we have ln of x into x cubed by 3 and minus integration over, take that 1 by 3 outside, you have x square d of x and plus c. So ln of x into x cubed by 3 and minus, we have 1 by 3. Okay, 1 minute. Minus 1 by 3
x to the power 3
into, again here you have
cube by
3 plus
3.
another constant c prime. Okay, we take another constant because we can perform one integration and there will be a constant, and by summing these two constant we will get another constant, integrating constant, which is c prime. So this is your integration. Okay, you can express that by 1 by 9 of x cube or in any other ways. Okay, so this is the integration. So now we comes to another combinations of this type of problem, how we can evaluate that integration over x sine of x dx. So here this is the algebraic expression and this is a trigonometric expression. Now which term will come outside? Algebraic term will come outside. That means you have x and then integration over sine of x d of x.
Dx minus,
and then minus, you have
perform
some ddx of x. Again you have to perform integration over sine of x d of x and with the dx. So that means x into sine of x means minus cos of x. and then again minus integration over here you have 1. For the sine of x, you have minus cos of x. And again, here is a dx and integration constant c. Now, these two minus term will create a plus term here and minus x of cos of x and with plus integration over cos of x d of x plus c. Am I right?
Yes, sir.
Yes, sir.
So now you can see the result from here, x cos of x
Sin
and
x
plus
minus.
this is cos of x means sine of x and plus another constant which is c prime. Okay. Is that clear? Is there any doubt?
No, sir.
No, sir.
No, sir.
So now we come to another combination which is the exponential and sin x combinations in the last two terms. Nah, this is L, our rule L-I-A-T-E. This we take last two terms T and E. If we take that, actually e to the power x create a loop and sin of x also create a loop. It's never end. If you take one term outside and another term inside, you will never end the process because e to the power x will loop in this way. E to the power x again give you e to the power x, and sin of x taking the loop sin x to cos of x, again cos to sin of x, again sin to cos, again cos to sin. This type of loop will create whenever you try to take that integration. That's why there is this process of finding this type of integration. Can someone tell me what is the process?
Sir,
How
I
we
take the
can
integration of
I
e to the
is
power x
equal
sin
to
x dx.
Actually, we have to take I in this type of integration. Absolutely right. So we have to take I is equal to integration over e to the power x into sine of x d of x. And we take that sine of x term outside using our rule. And so there is sine of x outside, integration over e to the power x d of x, and then minus integration over what? ddx of the outside term, which is sine of x, and integration over the inside term again, d of x, and after performing that, you have to calculate the integration again. So what do you have? You have sine of x e to the power x, na? Sine of x e to the power x.
Yes, sir.
Then minus integration over sine of x will give you cos of x. And this e to the power x will give you e to the power x and dx. Dekho, again, we create a loop which contains a trigonometric function and an exponential function, and it will never end. So we take a constant here. This is c. So now our problem is sine inverse x into e to the power x. Again, we perform that integration, and
that
which will
will be
give
sine
you
x. So
cos
that
of
will
x
be
outside.
sine.
Yes.
That will be sine
Not
and
sine
not
inverse
sine
x,
inverse.
x.
X to the power.
Not
So
sine inverse
this
x,
is
sine x.
yes. Sorry. This is sine of x. Thank you. So this is sine of x into e to the power x. So now we have cos of x into integration over again e to the power x d of x, and then again take minus over the integration what ddx of cos of x, na? ddx of
Yes,
cos
sir.
of x, again integration over e to the power x d of x, and followed by another integration. So this is the term and plus that constant c. So what we have? So actually we have sine of x e to the power x into and minus cos of x into e to the power x e to the power x,
Sin to the power
and
x.
there is minus of minus plus, and again you have one minus from here, na? Minus sine of x. Actually, you have
Yes,
three
sir.
minus here. One minus here, another minus is here, and another is here. There are three minus terms. So that means actually it will give you a minus term on the outside. And there is integration over sine of x into e to the power x into d of x and plus c. And it is the term which is called I. We take at the starting of our problem.
Yes,
so
yes,
this
yes.
term is identified the I term. Okay. So now we got that I is equal to sine of
Minus I equal
x
to I.
into e to the power x minus cos of x into e to the power x and minus I and plus an integrating constant c. Okay, we change that integrating constant to c prime because there is another integration. So if we take that I in the left side, so 2i is equal to e to the power x into sine of x minus cos of x. We rearrange in this way, cos of x and plus integrating constant c prime. So your integration value I will be e to the power x by 2 into sine of x minus cos of x and plus what? Plus c prime by 2, and which you can take another constant c double prime, okay, in the next part. So this is the process of integrating this type of loop function by using the by parts. If this type of loop occurs, so you have to take one I and then you can take that in the left side to perform the integration. Okay, so that's all about the integration by parts. Is there anyone have you any doubt about that? Is there any doubt about that integration by parts method or the previous methods?
No, sir.
No, sir.
No, sir.
Not. So then we comes to some special integrals. Okay, we will not discussing that in details for the third part. So you can easily see this type of formulas. Suppose ddx of a square minus x square is equal to 1 by 2a ln of a plus x a minus x. Are everyone familiar with this type of formulas?
Yes,
See this type of formulas.
Yes,
So these are some special types of integration. That means whenever this type of integration occurs, that means ddx of suppose 9 minus x square, or suppose this type of integration ddx of x square minus 9, or suppose this type of ddx of x square plus 9. So these three are the formulas of this type. So whenever 9 minus x square, that means you can express that in the 3 square minus x square term, where a will be 3. So you can use this formula. That means what you have to do, whenever you take 9 minus x square, so this 9 is equal to dx by 3 square minus x square. Na? So just put a is equal to 3 here. Here 3, here 3, you have to put that, and here also 3. Just put 3 in place of a. And for all problems here, for every problems here, we take the same a values. Here also 3, just the patterns are different. Here we say that 3 a square minus x square. Here we take that x square minus x square, and here the x square plus x square. Actually, you know that formula. This is the tan formula, 1 by dx by 1 plus x square. You know na? Okay.
Yes.
Yes,
1 minute. And here just take another constant 1 by a, and so you have to divide that. You have to divide that by 1 by a. So this is tan inverse x by a, 1 by a. So these formulas can be used in this type of formulas. So I will take on problem. So integration over dx by 32 minus 2x square. Is there anyone who can help me to solve this type of problem? First, what we have to do?
Sir,
we have to take common of 1 by 2 from this, and then 4 square minus
we
x
take 1
square.
by 2 outside dx, and it will makes it 16. That means 16 means 4 square.
4 square minus x square.
So this is a part, and where you can use this type of integration. And what is the type of that integration? This is integration over a square minus x square term, and you can use this formula to solve that. That means 1 by 2 into here you have 4. Now, with ln function of that 4 plus x and by 4 minus x of d of x, and there is an integrating constant c. So this is the process how you can easily solve this type of problem. That means 1 by 8 into ln function of 4 plus x by 4 minus x and plus c. Okay. So next problem is of the second type, and which is the
previous problem. There will be one more.
Okay. Just 1 minute. I will check that.
1 by 2.
Oh, yes. There is one again. I missed that. Thank you.
1 by 6
for that. So there is 1 by 2 for that term, and there is 1 by 2 for this term. So 1 by 2 into 8, that means this is a 16. 1 by 16 into ln of 4 plus x by 4 minus x. And for the second part, you have the evaluate integration over x by x to the power 4 minus 9 dx. And now help me to solve that.
Sir, here
x square whole square minus
square equal to
integration x by x square minus
firstly x by x square minus
I will not get my
The
answer.
integration of
It
x
will be x square minus
divided by
3 square.
x square whole square minus 3 square.
Integration over
X by
what?
x square whole square minus 3 square.
3 square.
But why we can use that? Actually,
we have to
substitute करो ना. So
So
substitute
x
करो.
squared equals to
Sir,
t.
x square is equal to t ধরলেই
Put
হবে।
x square is equal to t. It will be easier. That's why we use the substitution method, na? Put x square is equal to t, and it will gives you 2x dx is equal to क्या? dt. Okay. So that means your x dx is equal to dt by 2. Okay. Now replace that here. So actually you have integration over. So x dx, this whole term will give you dt by 2. And this x to the power 4 terms will convert it to t square minus 9. Na?
Yes,
that
sir.
means 1 by 2 integration over dt and by t square and minus 3 square. Okay. So
Yes.
now you can use this formula. That means the x squared d of x, here is the formula. That means 1 by 2 into, again you have 1 by 2a. That means 2 into 3 into ln of x minus a. That means 3 and by x plus 3 and plus c. Am I right? That
Yes,
means 1 by 12 into ln of mod of x minus 3
Sir, it will
by
be
x
t.
plus.
Sir,
So it
it
will be t.
is t, sir. X square equal to t.
Oh, it is t. Okay, we have to replace that t again, na? This is t and this
By
is the term x square. Okay, so this is the t and this is the x square term, and it will gives you the answer. That means ln of x square minus 3x square plus. That is the usage of substitution. By substituting something, you can make easier the integration. So now we have written another part, and which is evaluating this type of integration. Now this is not on the actual form, and someone help me to.
Yes, we have to first
break
divide
that.
1 by 9 and then multiply our method.
What we can do?
First,
Take 1 by 9
common.
Dividing that by 9.
1 by 9 common, taking common.
Okay, so if we take
No, sir, by
1 by
breaking it
9,
into, so we can break 8 into 4 plus 4.
4 plus
Sir,
4
we can do
actually.
middle term factor.
Absolutely right. Absolutely right. Not, you don't
Sir,
need
the
to middle
middle
term. Actually, we want this type of expression: x square minus a square, or x square plus a square, or a square minus x square. Okay. Actually, you can see that you have x square type of material, so we can put in these two type of form. We actually try to rearrange this in this type of form, something of square and minus some constant square, this type of form. So that's why if you take that, you can for after one step you can get that dx. 9x can be expressed as 3x square, right?
Yes.
And minus, you can take that 2 into 3 of x. Now to make that 12, what you have to multiply? 2, right? To make that 12, what you have to multiply? By 2. And to make the square portion, you need another 2 square term. So now you have total 8. That means someone says that break that 8 into 4 plus 4. And he's absolutely right. That means there will be another 2 square term. Na? So this 4 plus 4 makes this 8. Now combine this whole term, and which will give you dx by 3x minus 2 square and plus 2 square. Okay. Am I right?
Yes, sir.
Yes, sir.
So now performing that, what now we have to do? We have to substitute something. We substitute 3x minus 2 is equal to t. That will gives you 3dx is equal to dt. Na? So that means dx will be dt by 3. And now take that term, integration over. So dx is equal to dt by 3, and by you have t square and plus 2 square term. That means this is x square plus a square type of term. And you can easily integrate that by using this rule. That means 1 by 3, we take that outside, okay, this 3, dt by 3, we make the terms outside 1 by 3. And after performing this integration, that means t square plus 2 square of dt, actually what we have 1 by 3. Then for this term, you have 1 by 2 into tan inverse of t by 2 plus c. Is that right?
Yes, sir.
Yes, sir.
Now you have 1 by 6 into tan inverse. T means 3x minus 2. 3x minus 2 by 2 and plus c. And this is your integration. This is your required integration. Okay. So there are so many terms, not only for that x square plus a square. Yes, yes.
So that's stage 1, please.
Yes, yes. Okay. See that.
Okay, sir. Okay, done.
Okay. So now these are the formulas which actually constant x square minus 3 not of root time, and you all know that there are formulas with the root time, and you are familiar with this type of formulas also. Just see one times and you can perform this type of problem. I think you are familiar with this type of formulas also. If this type of forms occur, x root of x square minus s square, then you have to use this formula. And the problems actually look like that. That means integration over dx root of 4x square minus 9. So what you have to do in this type of formula, actually you can take that as an assignment. Okay, and these are the same process. So first you have to take that 4 outside. Make the x free. This is the rule. Make that x free. If it contains some constant, here dekho, x may constant hai na? So make that x free first by taking common. So if you take 2 outside, then your integration will be in this form. Dx by, you will take 2 outside into root of x square minus 9 by 4.
By 2 whole square.
That means 3 by 2 square. Actually, this 9 by 2 will be 3 by 2 square. That means this is your a. Your a will be 3 by 2. Just put in this formula and you will get your answer. Okay. So this is the process. But one thing you have to remember, make that x free first. If there is any term combined with that x, you have to take that outside and mix the remaining term as per this way. So in the second term, you have another expression which will consist of x square plus s square, one for minus, another for plus. So only changes is here. You can identify. This is the only changes here. This is the only change. There is no change. Remembering that. So a minus, here is plus. This is minus and this is plus. We have to change that. And the problem look like in this way. Okay. So what is the problem? Just 1 minute. This is the problem. And this is the next part, and which is, so if you have this type of problem, dx is equal to 16x square plus 25. So again, you have to make that x 16 common. So this will make your x free. And after that, there is a 25 by 16. That means 5 by 4 square. And this is your a value. So here, your a value will be 5 by 4. Then take it here in the formula. So, and there is another term which is a square minus x square type, and you all know that formula for 1 by root under 1 minus x square dx integration, this will be sine inverse x. Am I right? This is the sine inverse x formula, na? So yes, again, for the root under, there is a common term a square minus x square, you will get simply sine inverse x by a plus c, like the previous term where we discussed the tan part. Okay. So here, the problems of this type can be calculated. You can see that there is n minus 9 minus 25 x square. Again, you have to take the same action. Put that, makes that x free. That means you have to take what outside? Which number you have to take outside?
5 outside.
So we can also do substitution.
5.
No. If you use substitution, then there will be no terms and which will substitute your x square. Okay. It will not work with the substitution. If you take 9 minus 25 x square, then your differentiation will gives you this type of form, 25 into 2 of x dx. Am I right? That means minus 50 of dx. This type of terms will come. Or if you take a t square, then again also there is a x in your derivative. But there is no x in your numerator part, and it will not help you to substitute substitute. So that's why substitute type problems will not work in this way. So that's why we use this type of formula. Yes. Tell me.
So we have to take common 25.
Ekdam. We have to take common 25. So after taking that common 25, that means you will get 5 common in the outside. So after taking that 5, you will come 9 by 5 here, 9 by 25. That means this is 3 by 5 square, no? And this is your value of A. That means sine inverse, it will be x, y here 3 by 5. That means you will get a 5x by 3 terms. And in the outside, you have a 1 by 5 terms. So that's the way this type of formula works. So this is the 1 by type of formula. Then if we get in the next part, you can see that type of formula also, and which is of the simply root type of formula. Integration over root of a square minus x square dx. And again, in the similar way, you can solve this type of problem. I will give you that task, solve that problem and give me in the Telegram group so that I can see that from you and how many students solve that problem. Okay. So there are 3 problems I will give you as an assignment, and you can directly send it to my Telegram number. So there are 3 problems which used the simple roots formula. So first, there is the same way you have to free that x, and after freeing that x, just you identify what is the value of a. So this is your target. First free the x, okay? So free the x. x को पहले free करो, उसके साथ कोई भी bound है तो उसको यहाँ से छोड़ दो, okay? उसके बाद you can apply the rule to calculate your integration, okay? Is it clear to everyone?
Yes, sir.
Yes, sir.
Yes,
Okay.
yes, sir.
So here there is another interesting part which is called the integration using partial fraction.
Sir,
Okay.
please show the.
Okay, just 1 minute. Okay, you can see that.
Okay, sir, done.
Okay.
So when we solve this question, we have to send it on your email ID.
Ekdam. No,
Sir, what is
directly
your
to my Telegram number. Actually, my Telegram number, I will put that in my screen. This is 8967.262102. This is my number. Okay. So you can note down that and you can make that number. Just save the number, and I am available in Telegram, and you can send me the solved problem. Okay. And I want to see how many of my students will solve that problem. Okay.
Sir, 8967262102.
Okay. This is my number, and you can take a snapshot of that. Okay. Yes. This is the previous page.
Yes, sir. Done.
Okay. So now it comes to another part, and this is very important for your remaining. Okay, I will remove that portion numbers because this got 8967 here 262102. This is my Telegram number, and now the next part is the integration using partial fractions. That how we can partially factorize a terms for using that as so that it can make easy of the integration. So which type of integration generally occurred here? Suppose this type of integration comes, that means 3x plus 2 by some x square plus 5x plus 3. Okay. Or suppose this type of integration come, that integration over 2x plus and simply 2 by x plus 3 into x plus 2, x plus 2, or maybe there is x plus 2 square. So if this type of integration occur, first we have to partially factorize that term. Then we can use the integration. Otherwise, it is difficult to calculate because there are 2 terms and 1 terms with the degree 2. So it is not possible by using by parts or any other method. Possible, obviously, but it is very tedious to calculate. So that's why you use first the partial factorization method, and then we can perform the integration. Okay. So let's make a closed view of that. So what is partial fraction? What is fraction? You know that. And what is proper fraction? I think you also know that. What is proper fraction? Someone please tell me what is proper fraction? when we say that P of X by Q of X is a proper fraction. This is a rational function, no? This is a rational function. And when we say that this is a proper fraction.
When P is less than
Q
Q.
of X is greater than P of X.
Not in the sense of P. When the degree of P, degree of the polynomial P is less than degree of the polynomial Q. That means this type of term, suppose 3x minus 2, and in the denominator you have x square plus 2x plus 5. Okay. That means the numerator, degree of the numerator is 1 here, and the degree of the denominator will be 2 here. So this is a proper fraction. Now if x cube occurs here, now this is not a proper fraction, this is an improper fraction, and you can make that proper by dividing that. Okay. So not making, you can take the proper part, improper part outside, or the separate. That means if you take that 3x cube and minus 2 and then x square plus 2x plus 5, if you divide that, you get some quotient and you get another remainder here. No? This type of term, and this remainder will be of less degree than your numerator. And you can, in this way, you can make that as a proper fraction. Suppose this is P of X. So you can make that P of X is equal to something phi of X into some Q of X function. This R1X is of degree less than the P of X. And in this way, you can mix, or you can actually separate a proper fraction from an improper fraction. So after all of this separation, if you have a proper fraction, then one statement or one principle tell you that if that any proper rational function P of X by Q of X can be expressed as the sum of rational function and each having the simplest factor Q of X. So let's understand this by taking some example view. That means if this type of example is given, suppose 3x minus 2 and here x minus 3 into x minus 2 square. This theorem says that this proper fraction, you can express that in this way. Something A by x minus 3 plus something B by x minus 2 and something C by x minus 2 square. Okay. So any proper rational function can be expressed as a sum of rational functions, each having a simplest factor qx. देखो एक एक करके factor है in every terms. So after calculating that, you can integrate that because now these are separated. Okay, is that clear? Now we don't know about the A, B, C. We have to calculate that. We have to find that what is the value of A, what is the value of B, and what is the value of C. And actually this process is called the decomposition or resolving of the function into a partial fraction. So this is the decomposition process, and we will learn that process, how to decompose a rational function and into some easiest or the simplest form so that we can perform the integration. Okay, so now take a close look to this format, what you have to select and which type of denominator you have to choose. So suppose in the denominator you have simply this type of form. You have simply this type of form. Suppose simply 1 by x minus 2. So you have to do nothing. Actually, it is done. यहाँ पर कुछ भी नहीं है तो हो गया ना. So suppose this type of terms occur, x minus 2 square term occur. Then you have to take first term a by x minus 2, and then for the second term b by x minus 2. Okay. Is there any doubt? Dekho, you have to.
Please.
No, sir.
Yes. Is there any doubt? I can proceed.
No, sir.
So suppose this type of terms occur. The second term, we comes to the second part. If there is x cube, that means 1 by x minus 2 cube type terms occur. That means first term will be a by x minus 2. And what is the second part? What is the second part? There.
b by
x whole square.
X minus 2 whole square. And what is the third part?
c by x minus
2 whole cube.
Okay, and this is the process. So now if we increase the power of the denominator. So there is everything actually x is a power 1, degree 1. But if we increase the power of that x, that means if we take 1 by if we take this type of term, suppose 1 by x minus 2 into x square minus 2x plus 3, this type of term, then what you have to do? So for this x square minus 2, you can take that a by x minus 2. There is no way. And but for the second part, which is a second degree portion, you have to take one first degree polynomial in the numerator. That means ax plus, so we already take a, so we take another b, and with x plus c, a second first degree polynomial, and with x square minus 2x plus 3. Okay, is it clear? That means whenever your x is of degree 1, you can take constant part. A, B, C, this is a degree 0 polynomial, you can take the constant part. But whenever you use the factorization with the second order portion, second degree polynomial, so you have to take a first degree polynomial and you have to follow this process. That means whenever you have a cube degree polynomial, you have to take a square portion here. That means whenever you have this type of problem, that means some function 2 of x plus 3 by suppose x minus 2 square into x square, and not x square, x cube plus 2x plus 5, this is formed. Then for this part, you first divide that by a by x minus 2. And what is for the second? What is the second part?
b by x minus 2
square.
B by x minus 2 square. Na? And for the second part, what will you take? For the second part, what will you take? Someone please tell me.
cx square
We have cx square
plus dx
d of x and plus something e. What is your name and from which department you are?
तन्मय कुमार CSC.
ओहो तन्मय, मैं तो आपको जानता हूँ एकदम. So a by x minus 2 and b by x minus 2 square, and you have to actually, I want to say that if this polynomial have a degree 3 and you have to choose a 1 degree less polynomial in the numerator, that means that here actually the total polynomial have a degree 2, but here this x minus 2 consists of degree 1, so we take here a constant polynomial, and here also 1, so we take constant polynomial. But whenever this x directly refer to that x cube term, you have to take second degree. If this is x square, you have to take a 1 degree polynomial here. This is the process. So let's try one example, and after that we will come to our next problem. So we'll perform one problem here. So actually this is a problem, and due to less time for this topic, actually we consider the second problem, and which will you can take the previous problem as a home assignment. I will take a snapshot of that. After performing the first problem, you can solve that, I think. Okay, so just 1 minute, and this is the first problem, I think. What is that? Okay, just take a snapshot of that. After performing this problem, you can easily solve that. 2x plus 3x minus 3x plus 1. Actually, what you have to do here? You have to do that 2 of x plus 3. That means you take that as a by x minus 3 and plus something b by x plus 1. Then you have to simply calculate that with a apply x plus 1 and plus b into x minus 3, and here x minus 3 into x plus 1. Now after that you have to perform what? You have to take the coefficient of x and constant separately. That means if we compare these two terms, you have 2x plus 3 is equal to simply a into x plus 1 and plus b into x minus 3. So that means this will be x. And what is the coefficient of x? Here coefficient of x will be a, and there is b. That means a plus b into x, and plus here you have a minus 3 of b. Now you can compare these two terms. That means this a plus b will be 2. your a plus b will be 2, and this a minus 3b will be what? Will be 3. No? Just solve that problem. You take that minus here, take the elimination process. Okay. What do you get? Am I right here?
It's a b
Let's check once
equal
time.
to minus 1.
B equal to 0 minus
So
4b.
that means you have 4b, yes, is equal to what? Minus 1.
Minus 1.
That means b is equal to minus 1 by 4. Okay.
Yes,
Then what is the value of x? So we have a minus 3 here, and value of a will be 2 minus of 4. Na? That means 2 plus 1 by 4. 9 by 4. Is that correct? Okay. Let's check that. So we have 2x plus 3 is equal to ax plus 1 into b into x minus 3. That means here is a plus b coefficient, and here a minus 2b coefficient. So the first term will be the 2, and the second term is equal to a minus 3b, and which will be 3. And if you take the elimination process here, actually you have 4b is equal to minus 1, which will b is equal to minus 1 by 4, and this a is equal to 9 by 4. So what you have to do, just put that a and b here. That means you have here a is equal to 9 by 4 into 1 by x minus 3, and minus 1 by 4 into 1 by x plus 1. Okay. Did everyone get it?
Yes, sir.
Then you can perform that integration. I think it is easy to integrate. You can integrate that. So after integrating from here, you got some ln function of x minus 3, na? And from here you have ln function of x plus 1. Am I right?
Yes, sir.
What will be the integration? You got that ln function here, and from here you got the ln function of x plus 1. So that will left to you, and you can solve that problem for the integration part. And there is a similar problem, and which comes with a x square plus 1 terms. So how we can resolve that? Whenever we use 2x plus 1 by x minus 1 into x square plus 1, and how we can take the parts? Someone help me. Identify the fraction.
By x minus 1 plus
Sir,
1
can
by
you
x
show the
square
previous
plus 1.
page?
X square plus 1.
Yes. Someone.
Bx plus c.
Previous page.
B.
Okay. For the second part, you have actually x square plus 1, na? And what is the numerator?
Yes.
Bx plus c.
Actually, this is b of x and plus c. Yes. So after calculating that, you have actually a into x square plus 1, and here you have plus bx plus c into x minus 1, na? And you have x minus 1 into x square plus 1. Now, if you actually compare these two parts, you have the 2x plus 1 is equal to what? The coefficient of x square. That means ax square plus a. Here you have bx square, then you have minus b of x, then you have plus c of x and minus c. So if you rearrange that, actually you have a plus b into x square, then you have plus c minus b into x and plus a minus c. Now take the like term. Actually you have a plus b. What is the value of a plus b?
0.
Is equal to 0. There is no part containing the x square. And for the c minus b, you have what? 2. And for a minus c, actually what you have? For a minus c, you have 1. Now take summation over these two parts. Actually you have a plus c is equal to what? 2. Now take the term here. Actually you have a minus c is equal to 1. And these two terms will give you 2a is equal to 3. That means a is equal to 3 by 2. Am I right?
Yes, sir. Yes, sir.
Okay. By putting that a is equal to 3 by 2, you can get your c. What is c? C is equal to a minus 1. That means 3 by 2 minus 1, and which will be the 1 by 2. And your term b, you can easily see from here that your b will be similar to minus a, and which is minus 3 by 2. So now just put that values here to perform this. So if we put that here in place of a, you have to put what? 3 by 2. That means 3 by 2, 1 by x minus 1. And then in place of b, we have to put minus 3 by 2. That means minus 3 by 2x. And in place of c, we have to put 1 by 2. And here you have x square plus 1. Okay. That means actually you have 3 by 2 into 1 by x minus 1. And if you take the minus outside and make a LCM over this 2, actually you have 3 of x minus 1 by x square plus 1. Am I right? Here?
Yes, sir.
Yes, sir.
Yes. So I think now you can perform the integral. Okay. Is that possible to perform that integral? Is that possible? So just divide these two terms. Okay. Just take that for the second part, 3 by 2 x by x square plus 1. इस तरह से ले लो. And for the second part, you take 1 by 2 into 1 by x square plus 1. Okay. So this term will give you tan inverse. In the second term, you can take x square is equal to t. You can use the substitution method here. And the first term will be solved by the simple log term. Simple log term. Na? So now you can perform this integration. You know how to perform that. Okay. Is there any doubt regarding this?
No, sir.
No, sir.
No, sir. No, sir.
No, sir.
No, sir.
Okay. So now we come to the definite integral, which you already see in our title, but due to the short of the time, our integration is a vast portion, not a small portion to discuss in 2 hour session. So if we come to the definite integral, so you know what is the definite integral. That means you have to perform the definite value of a integration from a lower limit to upper limit. That means between an interval. So this is your function. This is your function, and suppose this is the x value of a and this is x value of b. And actually integration means the area bounded by the curve and these two lines. So whenever you perform that, in the definite integral, we generally calculate the area under this interval a to b. A or b interval के अंदर कितना सारा area है, that will measured by this definite integral. So suppose f of x is a continuous function and defined over that interval ab, and then the antiderivative of f of x, you know that all of these things. So how you can calculate? After simply calculating this function, and you know that this is your primitive function f of x plus c. This is the indefinite integral and which is not unique and together with a constant function. Just put that upper and lower limit. So first you have to put the upper limit. That means first you take f of b. So if you take that, put that b here, you have f of b minus what? F of b minus c
Minus f of.
This is the term, and then minus you put that f of a and again plus c. So this to c will be eliminated. Then that's why definite integral will not contain any constant. So you will get that term f of b minus f of a from here actually. So now we'll perform this integration. So just tell me what is the integration of that. Integration over 2 to 4 dx by x. So this will be integration over 2 to 4. What is the integration value? Tell me.
Say x inverse. So minus 1 by x. Minus 1 by x minus
log 4 minus log 2.
This is a ln of mod of x, and in the interval 2 to 4. That means first term will be ln of
4 minus ln of 2.
Ln of 2. So that means ln of what? 4 by 2, na? Yes. That means
sir.
ln 2.
Yes, sir. Yes, sir. Yes, sir.
So this is the value. So actually one thing you have to remember, in the indefinite integral, there is an integrating constant and this is not unique. But the definite integral is always unique. It will not contain any constant. Okay. You can see that and take it as a notes. So now you can perform again this type of integration. Take it. Okay. You know how to perform that. And tan square x, d of x, how to perform that integration. Someone help me. How to perform that?
So 6 square x minus 1.
We have to take 6 square x minus
Ekdam take 6 square x and minus 1 into d of x. Now this 6 square x will give you tan of x. Huh? Tan of x. And then minus 1 will give you the x, and there is an integrating constant c, and in between the limit 0 to pi by 4. Now you know that the tan 0 will be 0, x will be 0, so lower limit will give you nothing. Only the upper limits will give you the value. Okay, so that means the tan of x, someone I think tell me the solution. Okay, send me the solution. So tan of x, that means tan of pi by 4. Yeah, and this is x for pi by 4, and c will cancel. So what is the value? 1 minus pi by 4. Okay, is that correct? Okay. So now we comes to another part, and you can see how to solve that problem of the definite definite integral.
We have to substitute x as cos of 2 theta.
But why? You can partially factorize that, na?
We can add also.
Actually, you can
add
make
1
an addition,
and minus
1 plus 1
1.
minus, na? Okay, so we can put that in that value 2 minus 1 plus x. Dekho, is it correct? 1 plus x. Okay, and after that you can simplify that integration. That means 2 integration over 1 by 1 plus x of dx and minus integration over d of x. Okay, so this will give you the, after putting the limit 0 to 1, they are also putting the limit from 0 to 1, and 0 to 1 you have the definite integral as 2 of ln of mod of 1 plus x and minus what? X, and in between the limit 0 to 1. Again, for the lower limit 0, log 1 will give you 0, and minus x also give you 0. Only the 1, there is a c obviously for the integrating constant. Only the upper limit will give you some value. And what is the value? 2, and then the function ln 2. Na? And minus, there is a 1. And this is the value of your integration. So this is some, actually you all know that. So after performing the indefinite integral, you just have to put the upper and lower and upper limit. Okay, so if you know how to perform the indefinite integral, you can easily do that. You can easily calculate the value of the definite integral. Okay. So now there is another term which is 1 to 2 dx e to the power x plus e to the power minus x. And someone help me how we can solve that.
E to the power minus x, and we written as 1 by e to the power h, and then we
integration over 1 to 2 d of x and e to the power x plus 1 by e to the power x. Na?
Then we will take
that
LCM.
Means integration over 1 to 2 into e to the power x d of x into, what is that? E to the power x square, na? Plus 1. Now what we have to put?
To t.
Bolo? We will take e to the power x equal to t. That means e to the power x into d of x is equal to dt, and your limit will change from, suppose this is x limit and this is t limit. So in case of here, when your x limit will be 1, your t limit will be e, and your x limit will be 2, your e limit will be t square. That means here you have to change the limit. That means from e to e square into what? This is dt, and here you have e to the power x square means t square plus 1. So you know what is the integration for that? This is tan inverse t, na?
1 by 2.
And this is tan inverse t plus c. So you just e and e square. That means tan inverse of e square and minus what? Tan inverse of e. Okay. So this is the value of the integration. So sometimes it will happen that you can directly put the limit, and after substitution, if you again take, if you put the value of t here, that means e to the power x. That means tan inverse, you can take that e to the power x, and then you can put the value 1 by 1 to 2, and it will also work for your problem. But we changes the limit according to our assumption, and it will, for this, you will not taken any extra step to solve that problem.
Sir.
Okay. Yes.
Sir, when there is limit.
Yes.
Is there any need to write?
When there is limit here, actually there in the definite integral, actually indefinite integral में c होता है, ठीक है? Actually there is a c. But if you don't take that, and this will not change your values, okay? Actually, if you take the step rightly, you have to give that C. Actually, it will not affect your answer. But if you want to make the process make them clear or right, so you have to give some C here. Is that clear?
Okay.
Value will be always same. But this is a right process. So give some C. Okay, or a right practice also. So now some important properties of definite integral, and which most of you already know that integration over a to b f of x dx will be a to b f of t dt. That means if you change that x to any other variable, it will not change your integration. Function will be the same. I think you all know that. Am I right? You know that?
Sir. Yes, sir.
Yes, sir.
And the second term is if you interchange the limit, that means a to b, if you take that from b to a, there is a negative sign with that. You also know that.
Yes.
And sometimes it is required to actually divide the integration into two parts. That means you can take that in this way. Integration a to b f of x dx will be taken as integration a to some c and then some c to b f of x dx. In this way, if you require that, I will say when it will be required, for which type of function it will be required. Then there is another term, if this type of integration occur, integration over minus a to a f of x dx, that means a symmetric integral if this type of integral occur. So there is a common properties, it will be 0 when this fx is an odd function. Na? So odd function, someone please tell me what is the odd function?
Sir, when f of x, when f of minus x is equal to minus of fx.
When f of minus x, if you take argument minus x, then it will give the minus of that function. That means suppose x cube function you take. This you take f of x equal to x cube. You take f of minus x, what will happen? This will minus x to the power cube. That means you have minus of x cube. Na? That means minus f of x. So that's why this x cube is an odd function. But if you take f of x equal to x square, then what happens? F of minus x will be minus x square
plus x square.
Same function f of x. Now f of minus x will be the same, and this type of function called
even function.
This is called the even function. So if this type of integration occur minus a to a f of x dx, then you can directly put it 0. First follow that this is a symmetric integral, okay, minus a to a, not for any other integration. If this is minus a to a, then your integration will be 0 if it is an odd function, and it will be in the form 2 integration over 0 to f of x dx. That means the integration is symmetric, area is symmetric with respect to that a. If you take that 0, they are a and they are minus a. So this integration is symmetric in both sides. You can take integration on the one side and take it double to perform the total integral. That means 2 over integration over from 0 to a f of x dx. And in this way, you can calculate the whole integral. Okay. So this is the process, and this is the place where we can use that. Suppose this type of integration occur, integration over 1 to 4 f of x dx, and this is a break function. And where there is a break in the point 2 to make break here. That means this function will govern with different rules. In between 1 to 2, this will follow the 4x plus 3 rules, and in between 2 to 4, it will follow the 3x plus 5 rules. So you have to separate that integrals into two parts. That means 1 to 4. Help me to perform that integral. How we can solve that? 1 to 4 f of x dx is equal to, from which point we break that interval?
1 to 2.
So we take 1 to 2 f of x dx, and then we put here 2 to 3. 2 to what? What? 2 to 4. We have to integrate up to 4. 2 to 4 f of x dx. And in this 1 to 2, actually the function follows 4x plus 3 rules. This is 4x plus 3 dx. And from here, integration over 2 to 4, it will follow the 3x plus 5 rules. Okay, so just calculate these two integration separately and you will get your answer. I think I did not need to solve that. Is that okay? Can you solve that problem?
Yes, sir. Okay.
Yes, sir.
Yes.
Sir, yes, sir.
This will left to everyone to solve that and as an assignment, and you can send me to my Telegram number after solving that. What is the answer? So now take another problem, which is of this type. Evaluate mod type of problem. Here is also a tricky term. If the integration, if is integration modulus term occurs, you have to break the interval again, because modulus are different nature in the different interval. I think you know that. We know that definition of modulus of x function. Modulus of x will be x. Now, when x greater than 0, 0 when x equal to 0, and it will give you minus x when what? X less than 0. Okay. Is there any doubt? What is the modulus of function? So in modulus function, there is 3 types of nature. And here also we have modulus of x minus 5. So x minus 5 will give you same x minus 5. If this x minus 5 greater than 0, if this is a positive term, that means if x greater than 5. Okay. And this will give you 0. What? If x minus 5 is equal to 0, that means x equal to 5. And this will give minus of x minus 5 if this x minus 5 less than 0. That means actually it will give you positive value always. If this is negative, then it will give you another minus to make that positive. So it will give you that, make it positive by using that minus. So this is the way. So that means here x minus 5 less than 0 will be x less than 5. Now we have 3 interval when one rule for x greater than 5, another for x less than 5 ना, यानी कि x के पहले एक रूल है, x के 5 के पहले एक, 5 के बाद में अलग सा रूल है. So we have to divide that integral because 5 occurs in between this interval from 0 to 8. Now that means integration over 0 to 8 mod of x minus 5 d of x will be broken into 2 parts. Where we break that function?
0 to 4.
0 to 5 and 5 to 8.
Exam 0 to 5 mod of x minus 5 d of x, and plus again integration 5 to 8 mod of x minus 5 of d of x. Now tell me, what is the rule for 0 to 5? What is the rule? What we take for 0 to 5?
Negative, so 5 minus 6.
So minus x
0
minus
to 5 यानी कि minus
5.
of x minus 5. So minus of x minus
minus
5 into d of x. And then you will take the plus term again. You will take 5 to 8, and what is the term? 5 to यानी कि greater than 5. That means x minus 5 into d of x. Okay. Now you can easily solve that problem, and it also left to you to solve the problem and send me after calculating that. This is a simple integration algebraic type. You can solve that easily. Okay. Did you solve that? Okay. Will you solve that? Is that okay?
Yes, sir. Yes, sir.
Yes, sir.
Okay. I think you all will solve that problem. My Telegram number is always open and you can send that. So now we take on problem of the second type formula for the odd even type formula. That means whenever this type of integration occur, minus pi by 2 sine cube x dx, and this is a symmetric type form, and this is a sine cube term. So your f of x will be sine cube term. Nah? So just check that, is that even or odd? That means you take f of minus x, what it will give? Sine of
Minus of
cube of minus x. Yes. That means sine cube, this is sine of minus x cube. Na? So sine of minus x will give you minus of sine of x to cube. That means actually you have minus of sine cube x. So what it? That means minus of f of x. So this is the odd type of function. Na? This is an odd function. So you can directly put that value will be a big 0. Okay. We have nothing to perform. Just checking that is that a odd function or even function, you can put that as a 0. Okay. So I think I have taken so much time to discuss all these problems. There is one part remaining in our discussion. I just introduce the application of this. Everything we discussed here actually have an application to find the area of the bounded regions. Actually, we already said that how to find the area between two curves, between two abscissa of a triangle. Let's see the picture. Actually, you can see this is the curve. This is the function, and this is the portion area and which is bounded by these two abscissa. One is x equal to a, another is x equal to b. Now, how we can perform this integration? Okay, how we can perform that? So here, if we take an infinitesimal, suppose strip, we take one strip here, infinitesimal strip. So what is the value of that height? This height will be y na? Is that y? Is that correct? Suppose this is y is equal to f of x. So at that point, so this is your y value. And if you take an infinitesimal strip of dx length, this is over the x, that means you take dx length. Now, what is the area of the rectangle? So now you have a rectangle, na? You have a rectangle which have a height y and breadth equal to 2x. Now, what is the area?
Y dx.
What is y dx? Now, what we take? We just expand this, na? We just expand this. So this is for an infinitesimal dx. Now we expand this from a to b. So that means whenever we take the integration from a to b y dx, this will gives you the actual area of that area of the area under the curve. This will gives you. So this is the process how we can calculate. So if this underside, if this is in the underside area, so you will take minus y instead of y. So there is a process. We are not discussing the details due to the short of time. So, but we want to give some basic ideas that how this type of integration used in our applicability field. So that means whenever this type of integration you have to perform, you have to integration that a to b y of dx. And if this area is in the underside region in this way, that means from a to b y dx, and which is in the underside, then this y is your minus of y, and this strip is of dx length. That means you have to calculate minus y of dx and from a to b, and this will gives your area of the integration. Now again, you can perform this type of problem, and I will not discussing that here. So using the integration, find the area of the region bounded by a straight line. So there is a picture of this type. This type, there is a picture, and which is 2y plus x equal to 8, and bounded by two curves. Suppose this is x equal to 2 and this is suppose x equal to 4. And we have to find this integrability area. This is our target. We have to find the area under the curve x equal to 2 and x equal to 4. So, you know, you have to calculate kya? Y dx from 2 to kya? 4. Right? You have to calculate the integration from 2 to 4, and you have to y of dx. So this is the process. So try to solve that. Okay.
দেখলাম অনেকে বলেছি যে ওয়ার্ডটা আমি জীবনে শুনিনি দিয়ে মানে বলছে আর কি অনেকে কি করেছে আছে তো সেই ওয়ার্ডটা সার্চ করেছে বিষয়ে
মিউট ইওর মাইক্রোফোন
বুঝতে পেরে গেছে বলছে আর কি ভুল মে
बताओ মিউট ইওর মাইক্রোফোন হু ইজ টকিং Okay, so actually this is the integration you have to perform, and this is the way. And the same problem you can say for the bounded region, and which is between the ordinates. That means if you take this type of space, if you take this type of bounded by two ordinates, that means y is equal to c and y is equal to d, then actually this is your x, and your infinitesimal strip is of height dy. Okay. That means you have to perform that with x dy, and which is from c to d. Now, c to d x dy. And similar for the left side. If the curve lies in the left side of the y-axis, then you take minus of x, and you can perform the similar integration. Okay. And so this is the figure, and this is the process how you can solve the area of c to d minus of x d of y. So this is the left side term, and this is minus of x and infinitesimal length of dy. Okay, so this is the pattern. So there is a problem, and you can snap that and try to solve that problem. So here is a x equal to y is equal to 4. This is this type of picture, and area bounded by the curve of a upper sided parabola, and with the line y is equal to 4 line, and which starting from 0 to y is equal to 4 line. So actually you have to make the area. So I say that these two area will be same. That means take that with 2 and integration over 0 to 4. And this is what is the length of that? This is length of x, na? X, and take that over the dy and make that x from here. So x equal to 4 root of y and put that value here, 2 integration over 4 root of dy, and calculate this integration to find your value. Okay. So similar process can be taken in case of a region bounded by 2 curves itself. If there is no bound, if this is bounded by 2 curves, one is f of x and g of x, and where f of x is greater than g of x, and it is bounded by to abscissa x equal to a and y equal to b, then your formula for calculating the area will look like c to d f of x minus g of x dx, this type, and here you have to perform, you can take a mod here, okay, to make that area positive simply. If g of x is greater than fx, then 1 minus a can be taken outside and take that mod to make your area positive. Always, area is always positive, there will be no negative term here. So in this type of problem, what you have to do, suppose this is a problem, fx is x square and x cube, and fx greater than equal to g of x in this interval 0 of 1. So your area will be what? Integration over 0 to 1 into f of x minus g of x and then d of x. That means integration over 0 to 1, your here x square and there here x cube minus d of x. And you know how to perform that integration. How to? X square means what? X square.
X cube by 3.
Okay.
X cube by 3.
X to the power
X to the power 4.
And 1, you know that how to perform that. 1 by 3 minus 1 by 4 is equal to 1 by 12 unit square. Okay, so this is the area of the integration. So I already taken so much time to discuss that, and I think it's 12:24 now. So thank you everyone for attending this class. Okay.
Thank you, sir.
I will end.
Yes, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.